Let's discuss about enterprise data center. So this is very important to understand before you deploy your NetScaler. Okay, so if you see this in any data center, you will have three types of segregation. One, you have internet on which all your client maybe resides, and then we have something called DMZ network. Sorry, yeah, something called DMZ network. So and then we have a internal LAN network. So let me tell you what is internal LAN network. Internal LAN network, it is nothing but a place where you are going to keep your all the critical servers such as your domain controllers, storage, etc., which should not have any visibility to the outside world. When I say outside world, it is to the internet. Okay, it should not have any direct exposure to internet. That is the appliance. All those appliances will comes under internal LAN network. Okay, so here you can see you have servers, you have storage, you have routers, switches, and client also. Client are nothing but your internal users which is sitting inside your network. Then we have a DMZ network. What is DMZ network? This is also also we are calling it as demilitarized zone network. Why we call it as demilitarized zone network? Because here we are going to place a device which is having a direct exposure to internet. Okay, so for example, let's say you have a public facing website. Okay, so that you need to deploy on the DMZ network itself. You should not deploy that on the internal LAN side. So DMZ is a place where we are going to expose your servers or websites or application to the internet. Okay, so all those things comes under DMZ. Then internet, which I already mentioned, this is the users which is sitting on the public internet. Okay, so all the traffic first should come to the DMZ if it is coming from the internet, and it should cross your DMZ internet, DMZ firewall or router or whatever. Then it will reach your servers which is hosted here. Okay, so your internet should not have direct visibility to the internal LAN network. So this is not at all recommend. It's not a recommendation. It's how that it is, because your DMZ only should be exposed and internal should not expose to anything outside. Okay, this is the enterprise data center architecture. This is how your most of the data center will looks like, and some data center may have some complicated architecture, but in general this is architecture you will find in any data center. So now the question is coming, NetScaler placement. So where to place, where to keep the NetScaler? Either I should keep the NetScaler in DMZ or I should keep the NetScaler in LAN network. So this is the scenario most of the people may come across. So let me brief you about this. So for example, let's say you have an application which is hosted in the DMZ. For example, you wanted to expose your websites to the internet. Okay, and those websites are, sorry, those servers which is responsible for the websites are in your DMZ network. Then you need to deploy your NetScaler in the DMZ, and then you can expose this to the internet. So this is how you're going to decide. You need to ask the customer where is the application hosted. Customer will tell my application are hosted in DMZ. Then you need to deploy your NetScaler in the DMZ itself. Okay, so this is one scenario, and the second scenario is NetScaler in LAN or internal network. Okay, so this is the scenario where your servers are in the internal zone itself. For example, your storefront server. So storefront server is not, you're not going to give that storefront server over the internet, right? So your storefront server is only for the internal users. So that time you need to deploy your NetScaler on the internal LAN network. You should not deploy on the DMZ and you can do the configuration. It has to be on the internal itself. So always keep it in mind. You need to deploy your NetScaler where your server exists, either in the DMZ or on the internal LAN. So you cannot deploy on the DMZ and you can configure the servers on the backend. So I'll come to that point. Such configuration also exist, but as a best practice, you also always you have to segregate. If it is an internal, you have to deploy it in the internal. If your service is in the DMZ, you need to deploy it on the DMZ network. Okay, and the third one is NetScaler in DMZ as well as internal network. So some customers, they have application which is also available in the DMZ and also available in the internal. So if he is having a budget constraint or budget issues to buy multiple NetScaler, then you can use the same NetScaler to do the load balancing of your DMZ as well as your internal, but it is highly not recommended. Why? Because for example, let's say if your DMZ network got compromised, then the attacker might get access to your NetScaler, and through NetScaler he can jump into your internal servers, etc. So that is why I always recommending to do the segregation. So even though customer is telling that I wanted to use the same NetScaler, you should highlight this risk. Okay, so if your DMZ network got compromised, because chances are compromising DMZ network are more because users having a direct access to your DMZ network, right, over the internet. So that is why. So you need to deploy your NetScaler accordingly. But although you can also use the same NetScaler to do the load balancing of your DMZ as well as internal network. However, there is a risk which I highlighted. So this is the three method you can use to deploy your NetScaler. So either DMZ or internal or both. So NetScaler appliance connectivity. This is very important. So most of the people who are working on NetScaler, maybe VPX, if they are not worked on MPX, they may have a question how I can connect my NetScaler to the switch. Okay, so for those people, I'm going to explain. This is how you're going to connect your NetScaler. So let's. Okay, so once you decide you're placing in internal LAN or DMZ, then the second part comes the connectivity. Okay, so how you're going to connect your appliance. So see guys, you have a switch, right? So you have a network switch. So to this network switch, you may have a backend connectivity to the servers or your computer, etc. So now you placed your NetScaler in the rack. Okay, so this is rack mounted, and now you need to do the cabling. Okay, so what you have to do, you need to connect one end of the cable to the switch and another end to one particular switch port. Okay, so this is switch number one and this is switch number two. Always make sure that you have two switches to connect your NetScaler for the redundancy. I will tell you why. So first cable you need to connect to the first interface. Second cable you need to connect to the second interface. Okay, different switches. First interface to the first switch, second interface to the second switch. Similarly, you have another appliance. This is for the HA. You may have a high availability, so you will have another appliance. So here also, first it should go to the first switch over here, and the second it should go over here. So this is how you need to connect. Why? Because let's say if this switch goes down due to some reason, power failure, whatever it is, so you'll have a redundancy of this switch. Okay, so this is the switch level redundancy we are talking about. Now coming to the interface level redundancy. For example, let's say you connected to this port, right? If this port is having any issue, let's say this port is gone due to some issue, then still you have another port connected to this to your NetScaler, so you'll have a redundancy on the interface level also. Okay, so for example, if you do not connect like that, then if this interface goes down, means your entire NetScaler may go down. So now if you are connected two cables, one for the one interface, another for the another interface, then you have redundancy over the interface level as well. Okay, this is, so we have seen switch level, we have seen interface level redundancy. Now coming to the NetScaler level. So now we deployed two NetScaler, right? So even though if this NetScaler goes down also, then still you have this NetScaler. So this is how you need to plan and you need to configure, or you need to connect your cables to the switch. So always connect two cables from each NetScaler to different switches, so that you'll have a complete redundancy over the failures. Okay, so hope this is clear for you guys. So as you may see, just to avoid confusion, I took only one NetScaler here. So I connected one cable to this and another cable to this one. Similarly, you need to connect the other NetScaler also to here and to here. Okay. So now going to the next topic, which is 1R mode, 2R mode, 3R mode. So somebody asked how I can consider which mode to go. So as the statement says, 1R mode, you can connect Citrix appliance to the network through a single VLAN. The appliance receives the request from the client on a single VLAN and it sends the request to the server on the same VLAN. So if you see here, let's say you have a network which is configured as single VLAN. It means your servers are sitting in this range, which is 192.168.10.5, 10.6, 10.7. Okay, this is the same VLAN. Similarly, on the NetScaler also you configured the same, which is 192.168.10.3, 10.4, 10.5. So in this case, everything is on a single network or single VLAN. Okay, so in this case, we are referring this as a one hour mode where all your servers and your NetScaler you're going to deploy it on a single VLAN. So you're not introducing complexity. So it is very simple configuration. So this is referring it as a one hour mode where everything is on a single VLAN. So you need to ask your customer when you are going to deploy, what is my server range? What is the server VLAN? And what is the NetScaler you wanted to configure? Okay, so if the customer says that no, I don't want complexity, I want everything in a same VLAN, then it is referring then we are referring it as a one hour mode. Sorry. So now coming into the second part, which is 2-hour mode. So in 2-hour mode setup, you connect the Citrix ADC appliance to the network through two VLANs. The appliance receives the request from the client on a one VLAN and send the request to the server on the another VLAN. So if you see this diagram here, so here you see 192.168, 10.5, 10.6, 10.7. So these are all in same VLAN. Okay. So then you have something called something in red, right? VIP, virtual IP. I'll tell you what is virtual IP later, but this is a customer facing IP. Okay, this is the IP user will access. So now this IP is different, as you can see, 10.163.1.5. So it means this is in a different VLAN and this is in a different backend is in a different VLAN. Now two VLANs are involved in this configuration. So now this is called as 2-hour mode, where you are getting the request in one VLAN and you are sending that request to the backend on another VLAN. Okay, so this is called 2-hour mode. Okay, so here two VLANs are involved, one for the request from the client and another for the backend communication with your servers. And the last one is multi-hour mode. Multi-hour mode is nothing but here you have multiple VLANs involved. For example, let's say your server first server, it is in a 10.163.1.5. Second is 172.29.1.5. Third one is 192.168.1.5. So all these are in a different range and it is in a different VLAN. So similarly in ADC, if you see NSIP is in 10.183, VIP is 10.145, SNIP is a different 10.163, etc. So here we have involved multiple VLANs. So in this case, we are referring it as a multi-hour mode. So you need to do the config. There is no specific configuration for all these things. You just need to play in the routing part, how you will traffic, how you are going to do the routing for all these configuration. That's it. Okay, so this is how we are referring it as 1 hour, 2 hour and multi-hour mode.